So for my problem, I had contralateral cane in case D, and this is my free body diagram here. This is the hip joint axis, and on one side we have the hip abductor force pulling the pelvis downwards. On the opposite side of the hip joint we have body weight pulling the pelvis down, and the cane on this side pushing the pelvis back up. And I arbitrarily chose that rotation in the clockwise direction, so clockwise torques, are going to be abduction on the hip joint, and counterclockwise torques are going to be adduction. And I listed all of my variables here, so these were given to us. Body weight is 500 newtons, the cane force is 300 newtons. We're going to solve for the hip abductor force, and these are our respective moment arms. So the moment arm for body weight is 0.07 meters, for the cane 0.3 meters, for the hip abductor 0.05 meters. And I set up my equation as the abduction torques have to equal the adduction torque. So that would be the torque of the hip abductors added with the torque of the cane should equal the torque of the body weight. And so once I plug in all of my numbers right here, once I plug it in, I can solve for hip abductor force, which comes out to be 520 newtons. And for solving for the joint reaction force, we know that the sum of all the forces have to equal 0. And so I added the cane, the body weight, the hip abduction force, and the joint reaction force and set it equal to 0. And I arbitrarily chose that going upwards in the y direction is positive, and going to the right in the x direction is positive. But because all of our torques are perpendicular to the pelvis, we're only concerned with the y direction because they're purely torque and there's no shear forces. And so once I put in all my force values, cane equals 30, body weight is going downwards, so it's negative 500s. Hip abduction is also downwards, so that's negative 520. Once I add all those up, joint reaction force is 990 newtons, which means that the hip is compressing on the hip joint in the upward direction.